Hi, it's David McClymont here from DHM Environmental Software Engineering. Today I'd like to provide you with an overview of the HowLeaky decision support software, highlighting why it has been developed, its strengths and weaknesses, and showing you some of the key features of the user interface. HowLeaky is an Australian-based decision support software developed to assess the impacts of different land uses, soil conditions, management practices and climate types on water balance and water quality. It is based on a daily time-step water balance model called Perfect, which was originally developed back in the 1980s and 90s by Queensland government scientists. HowLeaky's development commenced 10 years ago and has been undertaken by scientists from Queensland's Department of Environment and Resource Management with limited funding from state, interstate and federal sources, with a lot of the development being undertaken by myself and others in our own spare time. HowLeaky is currently being used by a range of Queensland and Victorian government scientists, as well as private consultants, and is a key tool in Queensland's reef rescue project. So why was HowLeaky developed? The main reason was that we required a software which could reliably, quickly and easily provide water balance and water quality information for different land use studies. The original Perfect water balance model had been well proven over the previous few decades. It just needed a modern and more powerful graphical user interface. Also, around 10 years ago, another software package called Browser was being developed for time series visualization, and eventually the two packages were merged to form the basis of the modern HowLeaky. We believe that HowLeaky greatly simplifies the process of water balance modelling, allowing the user to concentrate on the science rather than fighting the graphical user interface. The flexibility of the interface allows HowLeaky to be used for evaluation, comparison, exploration and even optimization of land use management practices. The water balance model used in HowLeaky is a daily time-step model which employs a range of submodules for simulating things like crop growth, erosion and pesticide and nutrient transport. Recent modifications to the model have included the addition and refinement of pesticide, phosphorus, nitrate and solute model components. HowLeaky can simulate different land uses through defining different land use scenarios. A land use scenario consists of a range of template data consisting of station, soil type, vegetation, tillage, irrigation, pesticide, phosphorus, nitrate and solute information. So these are added into an empty scenario. The only requirements are that we have a location, a soil and one veg. The rest of the information is optional. So all of these template data are actually stored within HowLeaky's own database or series of databases that's accessed through the database tab here at the top of the window. Then we're presented with a range of headers for each type of template data, from soils, veg, tillage, etc. Any of these data types can be expanded to then show the values in that data. There's extra information involved in here. You can see exclamation marks, and these show what the default values were and how this has changed. We can double click on any parameter to add a comment to that parameter, so you can document your code. And also you'll notice a little question mark that follows me around as I go through the parameters. I can select that and I can actually get information about that parameter. So in this case here I clicked on senescence coefficient. It shows me the range of possible values, suggested values, and it also shows me where that parameter is accessed in the source code. So we're trying to make all of the science transparent to users. We can actually select a range of parameters to get a range of parameter information, and again there's all the source code that contains those parameters. To run a simulation, all you have to do is to click on any of the names of the scenarios and select an output that will show you what's happening. So in this instance here I've selected one simulation and we're actually presented in the main water balance report with a chart. If I select multiple simulations, then we lose our graphic and the data is simply represented in tabular form. I can also view the input parameter data for those selected simulations by the parameters report, and that shows us some different graphics and input information for all of the selected scenarios. And this is available as a rich text report. One of the key strengths of HowLeaky is its advanced graphical user interface that provides instant visualization and comparison of different land use scenarios. It does this through a range of reporting and time series analysis tools. So here's different reports that have been plugged into HowLeaky, and then we have a range of time series analysis tools in here as well that allow you to explore and interact with the outputs from the land use simulation. Now this toolkit is been incorporated from the browser software. We've embedded the code directly into HowLeaky, and we have access then to the full browser functionality. That allows you to present different views of the data and overlay and stacked views, to be able to zoom into the data and scroll through it, to be able to get tooltip interpretations of the data and convert from daily, monthly and yearly data as well. We can also view that as text and export to Excel, and then we can also do some other annotations of the data, such as putting planting information on, tillage information, any management practice we can overlay onto the time series, and we can also plot a trend line as well. There's other tools there for time series analysis, including monthly statistics and probability distributions. These distributions here have been stratified into different climate types, designated as El Nino, La Nina and neutral years. Another functionality of HowLeaky is the ability to drag and drop time series names on top of each other to create scatter plots. For example, I could plot total soil water against the pesticide in concentration in the soil to produce a scatter plot. And I could do that for a range of pesticides, and we can simultaneously compare and overlay different scatter plots to see the response. Now this feature becomes even more useful when you combine it with HowLeaky's rapid simulation speeds. For example, you can go in and change parameter values and see instantly how this affects the simulation outputs. So for example, here's the 2,4-D that we're plotting in this figure here. If we go and change the degradation activation energy to something like 20,000, you can instantly see how that changes the outputs. Similarly, when viewing the time series outputs, we can go and change any of our input parameter values and instantly see how that changes the resulting time series. If I double click on the soil icon here, I can go in and change some of the soil properties. So we might change runoff curve number down to 50, and you can see how that see how the variables update. So once again, this is due to HowLeaky's rapid simulation times that allows you to interact with the data.